Okay, so let's jump into the examples and then you'll be done with your first video and ready to tackle the assignment. So example 8 says show that f is continuous at x equals to 0. So what that means is that we know that the function is continuous, we just have to show it using the definition of continuity that we learned above. Okay, so the definition of continuity, the first thing says that f of 0 in this case, because we're wanting to show that f is continuous at 0, f of 0 has to exist. Okay, well I can show that it exists just by saying what it's equal to. So if I look at this piecewise function, for x equals to 0, this function is going to be defined at 0 on the very top branch. Because of the little equal to bar that's on the inequality sign right there, that means I'm going to plug into the top branch in order to figure out what f of 0 is. So that's going to be 1 minus 2 sine of 0. Okay, remember from the unit circle that sine of 0 is 0, and so f of 0 is just equal to 1. Okay, so the first thing is done. We have shown that f of c, which in this case is 0, is defined. The second thing that we want to show is that the limit as x approaches 0 from the left of this function and the limit as x approaches 0 from the right of this function are the same. Okay, so for the first one, the limit as x approaches 0 from the left, imagine plugging in numbers that are smaller than 0 to figure out what the value is. So if I'm plugging in numbers that are less than 0, that means I'm going to again use the 1 minus 2 sine x piece. And so if I plug in 0 to that, I'm going to get 1 minus 2 sine of 0, which we just calculated was 1. If I do the limit as x approaches 0 from the right of f of x, then that means I'm going to be using the second branch here, which is the e to the minus 4x, since that's the one that's defined for x greater than 0. Okay, so that's going to be e to the negative 4 times 0, which is just e to the 0, and I know that e to the 0 is also 1. So what that means is that since the two one-sided limits are equal, we can say that the two-sided limit is also equal to 1. Okay, so the third thing that we need to now say is that because f of 0 is equal to 1, and because of the fact that the two one-sided limits were both equal to 1, we know that the limit as x approaches 0 of f of x is equal to f of 0, which is equal to 1, and therefore, because of all of the work that we've shown, f is continuous, and I apologize for the bad handwriting here, f is continuous at x equals to 0. Okay, these are the things that you have to show in order to prove that a function is continuous. Okay, so you can't, oops, sorry about that, I was trying to get something off of my screen. You have to show all of these things. This is a complete answer. Anything less than this is incomplete. Okay, so if you have a question about that, then please let me know. Okay, example 9, the function f is defined by this piecewise function. Again, this thing is breaking off at 0, and this time we're asked, is f continuous at x equals to 0, and it says to justify your answer. So the way that we're going to do that is by using the definition, which we already learned, it's on the previous page of the notes, by the definition of continuity. Okay, so the very first thing is that f of 0 has to be defined. So f of 0 is equal to, again, because the equal bar is on this branch, I'm going to use the 3x squared plus 2x. So that's going to be 3 times 0 squared plus 2 times 0, which of course is equal to 0. Okay, so f of 0 exists, and it is equal to 0. So I move on to the next thing. The next thing is I have to figure out what the limit is on both sides of 0. Okay, so the limit as x approaches 0 from the left of f of x. Okay, and again, that's like me plugging in numbers that are smaller than 0. So that again would be the top branch right here, the 3x squared plus 2x. We just calculated that, and it was equal to 0. Okay. The next thing is we want to figure out what is the limit from the other side of 0 as x approaches 0 from the right side. Okay, well that's going to be the second piece, the e to the 2x plus 2. So that's going to be e to the 2 times 0 plus 2, which of course is e to the 0 plus 2. Okay, remember that anything to the 0 power is 1, so this is going to be 1 plus 2, which is equal to 3. Well, now I run into a problem because I got that the limit as x approaches 0 from the left was 0, but the limit as x approaches 0 from the right is equal to 3. These are not equal, obviously, and so what that means is that the two-sided limit does not exist. So what I say is that the limit as x approaches 0 without a superscript, because I wanted to say that the two-sided limit of f of x does not exist. So f is not continuous. Okay, and I do have to write this sentence in order to justify my answer. Not continuous at x equals to 0. Okay, so when you do these problems on the assignment, you're going to notice on my answer key that I say things very similar to the way that I'm doing these examples. So you need to get into the habit of doing it the way that I do, because that is what's required of you on the AP exam if you're asked to do a problem like this. Okay, last one, and then we can wrap up this video. So this says f of x is equal to 6 plus cx for x less than 1, and 9 plus 2 ln of x for x greater than equal to 1. If f is the function defined above, and c is a constant, and f is continuous at x equals to 1, then find the value of c. Okay, well I know that if f is continuous at x equals to 1, then three things have to be true. F of 1 has to be defined, the limit as x approaches 1 of f of x has to be defined, and those two things have to equal one another. Okay, well if I want to figure out what c is, then basically what I need to do is I need to figure out what the two one-sided limits are, set them equal to each other, and then hopefully be able to solve for c. Okay, so what I'm going to do is I'm going to first of all take the limit as x approaches 1 from the left of this function f of x. Okay, and so since this says x less than 1, I'm going to be using the 6 plus cx. So if I plug in 1 for x there, that's going to be 6 plus c times 1, which of course is just 6 plus c. Okay, so that's the first thing. The second thing is I want to now find the limit as x approaches 1 from the right of f of x. Okay, which in that case means I'm going to be using the 9 plus 2 ln of x, since if I'm plugging in x's that are bigger than 1, that means I'm going to be using this second branch. So that's going to be 9 plus 2 times the ln of 1. Okay, you do need to have memorized that the ln of 1 is equal to 0, so this is 9 plus 2 times 0, which is equal to 9. Okay, and then the very last thing, in order for this function to be continuous, I know that these two one-sided limits have to be equal, and so what I'm going to do is I'm going to take the left-handed limit, which is the limit as x approaches 1 from the left, 6 plus c, and I'm going to set it equal to the limit as x approaches 1 from the right, which was 9. And if I solve for c, I'm going to get c is equal to 3. Okay, hopefully that's given you the tools to be able to solve the problems on the assignment. And if you have any questions, then please feel free to contact me. And I hope it goes well for you guys. Talk to you later.